Alrighty, let's take a look at this question. So we want to prove that the exact value of the cosecant of 105 is square root of 6 minus square root of 2. So first of all, I think we should write this as 1 over the sine of 105 degrees. Because if we recall on our formula sheet, we really only deal with sine, cos, and tan, so not cosecant. So we'd start there, and then they want exact value, but really, as far as exact values on the unit circle, we know 30, 45, and 60, and then in other quadrants as well. So we need to think about 105 in terms of a couple of those angles added together. And what we could do is 105 would basically be 45 plus 60. So then we're going to write that as the sine of, instead of 105 degrees, 45 degrees plus 60 degrees. And then that leads us to an identity on our formula sheet, where we have an angle plus an angle inside sine, and that can be replaced with, and I know it's a pain, but keep writing down the 1 over, and we replace sine A plus B with sine, and in this case A is 45 degrees, cos 60 degrees, the B value, and then plus cos 45 degrees, sine 60 degrees. And now that we have basically sine of 45, cos 60, those are values we can actually get on the unit circle. So 45 degrees, the sine would be root 2 over 2, and then times the cos of 60, that's little, so 1/2, plus cos of 45, root 2 over 2, and then sine of 60, that would be big, so root 3 over 2. Okay, keep working on the denominator and keep writing that 1 over. So first we're going to multiply those fractions. So root 2 over 2 times 1 over 2, multiply the numerators. Root 2 times 1 would be root 2, multiply the denominators. 2 times 2 is 4, plus, again, multiply the numerators. Root 2 times root 3 is root 6, over 2 times 2, which would be 4. Okay, we're getting there. Now, keep the 1 over again. We're adding two fractions, so we need a common denominator, but yay, we have one. So keep that denominator 4, and then we can't actually add root 2 plus root 6, because in order to add radicals, the radicands, the 2 and the 6, have to be identical. All right, so now we're finally down to 1 divided by essentially a fraction. And if you recall, when you're dividing by a fraction, it's the same as multiplying by the reciprocal. So it'd be 1 times 4 over root 2 plus root 6, which, if you multiply by 1, it would just be that number. So 4 over root 2 plus root 6. Oh, we're almost there, but we still have to rationalize now that we have it like this. So to rationalize, we would multiply top and bottom by the conjugate of the bottom, since there's two terms on the bottom. So root 2 minus root 6, and multiply the numerator by the same. I'm going to keep the 4 not multiplied out, so we'll just keep it in brackets. 4 and the bracket root 2 minus root 6 over, in the denominator, we need to FOIL or expand those two binomials. Now, because they're conjugates, we really only need to do the first terms. Root 2 times root 2 would be root 4, but we could write that as just 2. And then the outside and inside will cancel off. Those, it would be negative root 12 plus root 12, that equals 0. And then the last terms, positive root 6 times negative root 6 would be negative, and root 6 times root 6 would just be 6. All right, we're almost there. We're almost there. 4 bracket root 2 minus root 6, all over top of 2 minus 6, which is negative 4. And then we can divide the 4 factor on top with the 4 factor on the bottom, and it would be negative 1, and then root 2 minus root 6 still in brackets. And why don't we multiply that out? So we'd have negative root 2 plus root 6, or writing that in a different order, root 6 minus root 2. And look at that. That was what we were trying to show it equaled. So root 6 minus root 2. Whew. Okay, there we go. Hope that helped.